Picture your after hours inbox messages arrive and your team still replies one by one. When replies are manual, details drift and customers see different answers for the same question. Open Twilio docs first, create a Twilio account, and then create API keys from the console before coding. Open the OpenAI Developer Quick Start, create your account, and generate an API key from the dashboard. Open the Groq Quick Start, register, and create a Groq API key if you want the Groq model path in this project. FastAPI is open source, so you do not create an account, but you should still read the request form docs we use later. Install ngrok next because Twilio needs a public HTTPS URL and your localhost address is not reachable from the internet. Run an ngrok tunnel on port 8000, then copy the generated HTTPS forwarding URL. Build both webhook paths from the ngrok base URL so Twilio points to your exact SMS and voice endpoints. Open your Twilio number settings, then set the messaging webhook URL to your public endpoint ending with Twilio Siemens. Set the Twilio request method to POST for messaging so FastAPI form aliases receive body and from correctly. Now set the voice webhook URL to your public endpoint ending with Twilio voice and keep method as a POST. Open your support agent file and add the first import so the code can read environment variables. Install the libraries you need: FastAPI for webhooks, Twilio for TwiML, and an AI client for replies. Import FastAPI and form because Twilio posts form fields to your webhook routes. Add messaging response next so your SMS route can build the XML Twilio sends back to the phone. Add voice response and gather so your voice route can return TwiML that captures speech. Import OpenAI as a client class so the same function can call a model for drafting replies. Import Groq as a second client class so you can switch providers without changing Twilio code. Create the FastAPI app object because every webhook route hangs off this one instance. Pick an AI provider with an environment setting so the app can choose OpenAI or Groq at runtime. Store the OpenAI key in a variable so your reply function can authenticate when OpenAI is selected. Store the Groq key in a variable so your reply function can authenticate when Groq is selected. Define a system prompt so the model drafts a support reply in your preferred tone and structure. Define maker reply so every webhook route can ask one function for a drafted answer. Guard against empty input because a blank SMS or blank speech result should never trigger a model call. Return a clear fallback message when the user text is missing so the phone gets something useful. Choose Groq when you selected Groq and a Groq key exists so provider selection stays explicit. Create the Groq client using the Groq API key so you authenticate the request before you draft a reply. Return the model content for the first completion choice and keep the rest of the API response hidden. Choose OpenAI when OpenAI API PY is present so the same function can run in a different environment. Create the OpenAI client using OpenAI API PY so the model call is authenticated. Return the model content string for OpenAI so Twilio always receives a plain reply message. Return a final instruction when no AI keys are configured so the agent never appears broken. Add the health route decorator so you can check that your webhook server is running. Write the health handler and return a small JSON object so the browser and curl can verify it quickly. Return an OK flag in health because this endpoint should not depend on any AI key. Add the Twilio SMS route decorator so incoming message form posts reach your server. Type the SMS function signature and match Twilio's posted field names with form aliases. Use FastAPI form alias to map Twilio's posted fields into your parameter names without guesswork. Generate the reply string by calling make reply with the inbound SMS body text. Create a messaging response object because it becomes the XML container Twilio expects for SMS. Append the drafted reply as the outbound SMS message so Twilio can speak it back. Return the messaging response as a string because FastAPI must send raw Twilio Twil text. Add the Twilio voice root decorator so your call flow has an endpoint to start the TwiML flow. Write the voice handler because this function is the endpoint Twilio calls to get TwiML. Create a voice response object so you have a TwiL container for the rest of the call flow. Create a gather block with speech input so Twilio listens to what the caller says. Add gather, say so the TwiML includes the exact prompt the caller hears. Append the gather block to the voice response so the XML flow actually runs. Return the voice TwiML response as a string so Twilio can interpret it immediately. Add the voice reply root decorator so Twilio can post the speech result back to your server. Type the voice reply signature with a form alias for speech result so your parameter receives Twilio's transcription. Draft the reply by passing the speech text into your reply helper so the AI has the caller's words. Speak the drafted reply with RESP, say because this is the TwiML instruction Twilio turns into audio. Return the voice reply TwiML as a string so Twilio can read it and play the audio to the caller. Start the server with UVCon so the webhook endpoints exist on your local machine for testing. Test the SMS webhook by posting form fields and confirm the server returns Twilio XML with a message body. Test the voice reply route with a speech result field and confirm Twilio XML includes a spoken same message. Recap the wiring: Twilio posts input to FastAPI, FastAPI drafts a reply, and FastAPI returns TwiML back to Twilio. Point your Twilio number to your SMS and voice webhook routes, then keep one human review step before you send.